Day. My name is Curt Fiedler, and I'm going to talk to you today about a photographic marker capture method we're using with our native tree snails. Hang on here while I share my screen. So my co-authors on this project are Scott Vogt, who works for Anderson Air Force Base Environmental Services, and Ms. Bea Daria, who recently graduated from the University of Guam Biology program. The snails, here are our actors. There's Partula gibba, Partula radiolata, and Samoana fragilis. Partula gibba is found on several Mariana Islands, including Guam, but the population sizes are really small on some islands in Guam, only in one location, and maybe not many more than 100 individuals. Partula radiolata is endemic to Guam. Samoana fragilis is endemic to Guam and Rota. All three of these species were listed as endangered by the Fish and Wildlife Service in 2015, at least based on the available data that they had then. It's important to assess the sizes and distributions of all three populations for the rare species. This will help us make critical management decisions to help them avoid extinction on Guam. For the widespread and now we know very numerous Partula radiolata, this may help us assess whether we can downlist a species or which habitats to prioritize based on their numbers. Marker capture surveys are an important technique because in the past we have not always used techniques that will give us good estimates of population sizes. Meander surveys, which basically follow a meandering track to figure out the presence of snails, aren't very good at getting counts. Fixed transects are a little better if they are done in a very organized fashion, but they still aren't going to get all the snails, and time counts of small restricted areas. All of these techniques leave something to be desired. A marker capture technique can give us better estimates, particularly for defined areas. It relies on repeat captures of marked individuals. It uses the ratio of marked to unmarked snails, or whatever animal you're looking at, that are sampled from a population to estimate the population size. If you're not sure how this works, Google Lincoln-Peterson Index. Marking snails, in order for marker capture to work, you have to have marks that are relatively permanent, easy to assess, and those marks can't affect the likelihood of snail recaptures. Some of the past work with partulids and other snails have used nail polish, different combinations of colors, super glue tags of paper, or marking with permanent ink and paint, like in this photo here. All these methods have inherent issues. We have no idea about the actual toxicity of these chemicals. Permanent ink is often not permanent, and it requires, application of these things requires handling and release, which poses a risk to the snails, and that handling time is it's time you have to use in the field, and you're going to need a permit from Fish and Wildlife Service. We came up with the idea of not marking snails and using a photographic method after we read a 2007 report by the U.S. Army looking at techniques and stuff on Oahu snails, and they recommended using a photographic method and abandoning physical marking techniques. And they also talked about a program called HotSpotter, a software package. Dave Sisko has used this, and he's given me some suggestions for its use. It's a freeware package from Rensselaer Polytechnic researchers, and it's been applied for a lot of different animal systems and is very robust. So what we did here is we developed the use of HotSpotter and a photographic procedure to get image data for partulid snails and analyze it. Well, this started off in 2019 and continued into 2020 to some degree before the pandemic happened. We, with Bea, we started developing this technique as part of her internship. It was a proof of concept. We had small sample sizes, and we basically learned how to use HotSpotter. Basically, she taught me how to use HotSpotter, and we worked out how to sample photos effectively. In 2020, I had a survey project as part of a cooperative extension agreement with NAVFAC, and part of that was to do marker capture surveys. We employed the photo marker capture method. Scott Vogt helped us refine it, and used the program Mark to analyze the data. We're currently using this technique for an Anderson Air Force Base survey with Scott. The first step in this process is basically figuring out where you're going to do the survey. You have to delineate the area, and you have to figure out when you're going to do it. The snails have to be, of course, present in this spot, and they have to be accessible. The search area has to be easily defined. You have to be able to go back and find the exact same area. And the size of the area has to be doable by the people that you have, your survey team. You have to repeat the survey at least 3, 5 times or more is better within a predetermined time frame. You have to find and photograph the snails. So you may have to use a systematic search pattern to cover the entire area. You have to photograph each snail at least from the lateral view, and we suggest a dorsal view as well to get size. You can record other metadata along with this, geocoordinates, plant substrate, and so on. We found it was best to not photograph small snails. So no snails smaller than 1 centimeter total length. Smaller snails, particularly Partula radiolata, have mottled color patterns. These may change with growth even within a week or two's time, and they're hard for the software to analyze. Small Partula radiolata can be mistaken for San Juana fragilis. If you look at these two, the photo here at the top, these two snails, different species. Can you tell the difference? And very small Partula gibba and radiolata also looks similar. Newborns are hard to tell apart. You also have to photograph each snail, at least from the lateral perspective, but dorsal perspective is helpful too, along with a ruler to get length. You may have to flex the plants to get the correct angle of view for this lateral view. Now, you don't have to take it exactly like this. It could be upside down, sideways, or whatever, but you have to have this side of the snail. You can rotate and crop the photos later on. The digital camera we used was this guy, a Olympus OMD 2 or 3 with an integrated macro lens and macro flash attachment. All these are weatherproof, light package, perfect for our uses. The TG cameras, the point and shoot cameras that they make are also nice, but we weren't able to get consistent results with them. You import after you get the photos, you import them in Adobe Photoshop Lightroom. In the catalog module, you add your metadata, plot, size, snail number, etc. And then you use the develop module to crop, rotate, and white balance each photo. And you want to fill the frame with the lateral view. You export them as JPEG images to less than 1 megabyte of size. I think most of ours were less than 500 kilobytes. In Hotspotter, you import the images into Hotspotter for all the sampling dates at once, and you have to define the area that you want the program to analyze for image comparison. Basically, we just cropped it to the entire shell, so a square image or rectangular image around the shell. And then you have to query each image one at a time, compare them with all the other images in the database. And you start with the first image that you took on the first day that you sampled. Hotspotter will spit out the top 6 matches and assign a score. And you should use those scores for their relative numbers, not their absolute numbers. When you evaluate those matches carefully, you choose the ones that are indeed matches, and Hotspotter has some tools to help you do this. They'll have these little circles and ovals that indicate the same features on each shell. You then rename the ones that match to the first first iteration name, and you sequentially query all the snails according to date. You can then recode it in Excel, export it as an CSV file, and work on it with Excel, and then recode it for use in Program Mark or other packages. This technique works very well, we think. Hotspotter is good at matching radiolata and fragilis, San Juana fragilis photos because they have lines and or blotches respectively. It's not as good, well, we're not really sure yet because our sample size is really small for Partula gibba, and that's because their shells don't have those pattern features. However, there are differences in shape and other things that you can use. We were able to do it, but our size was pretty small. Recapture rates that we got were really good. We got between 18 to 38% recapture rates for our small plots that we sampled only 3 times, and comparable recapture rates for larger plots. One of the problems with this is if you're going to try to sample snails up high in the trees, you cannot. You can't get quality images for snails up in the canopy on leaves without good lighting, of course. And even with the long telephoto, you can't get the right aspect of snails like this on the bark of this pugo tree. Not every location with snails can be assessed with photo marker capture. The snails may be too high up or not accessible for whatever reason. No low branches or understory means no or few samples. You also need a good team of experienced field biologists, experienced with snails. We found that you need at least 3 for 78 square meters, 3 people. More is better. You also need more work on the back end for this technique, but less on the front end that you would use with physical marking techniques. The hotspotter software is also on it's disappeared from the RPI website and its future support is unknown. I can still get you a copy if you really want. And we're already starting to look at other image recognition software. So despite some issues, most of the issues that we had are also problematic for traditional marker capture field techniques. But the ability to get a good estimate of population size for a defined area without directly handling these rare and endangered and fragile animals makes photo marker capture a valuable tool. Having a visual record of snails may also be useful for longer term studies on populations. That's having that snails recorded on digital, recorded digitally is maybe important. I want to acknowledge the UOG Biology Program and Lewis Stokes Alliance for supporting Bea during our early work. Both NAVFAC and Anderson Air Force Base have supported our survey work. And of course, I want to thank the Snail Team 6 members for their help. Thank you very much. And if you have any questions, I'll entertain them now. Sorry, this was fast, but 12 minutes is a very short time.